Welcome back, and today we're looking at waves. And to start us off, I've got the old physics favourite and toy that never seemed to go downstairs correctly, the slinky. The slinkies are great for demonstrating waves for several reasons. One, we can identify the different types of wave that we're dealing with. So for example, if the wave is travelling this way and then back to me, but the vibrations are going up and down, like so, then that is what we call a transverse wave. Light is a transverse wave. The waves that you see on water are transverse waves. And a transverse wave is one in which the wave travels in one direction, but the vibrations travel at right angles to it. Okay? The other type of wave that you come across is what's called a longitudinal wave, and the classic example of that is sound. In that case, the wave is travelling in this direction again, and it will be reflected here and come back, but the vibrations are also going in that direction. So the vibrations of my slinky are going forwards and then backwards, and that's the way the wave is going as well. So longitudinal waves, sound waves for example, are waves in which the direction of motion and the direction of vibration is the same. We can also look at changing the frequency of the waves using a slinky. So if I have a fairly low frequency, I have a wave that's going fairly slowly. Now this is quite a small slinky, but I should still be able to increase its frequency a little bit. And if I can do, we can see that we start to see a greater number of peaks and troughs. A peak being at the top, a trough being at the bottom. So, the higher the frequency of the wave, let's try again. The higher the frequency of the wave, the more peaks and troughs you will see, or the closer together they will be. And the lower the frequency, the fewer peaks and troughs you will see. Okay, so a peak is when it's like that, trough is when it's down here. In the middle, that's where it will be at equilibrium, and as it passes up, above or down below, the furthest it reaches from the equilibrium is called the amplitude of the wave. So watch out, it's not from the top to the bottom, it's from the top to the middle, or the bottom to the middle. Okay? The wavelength is very easy. The wavelength is simply the distance from one point on a wave, say the peak, to the same position on the next wave, so the next peak. Okay? You can also take it as being the position from one dip to the next dip. The other thing that's really interesting about the slinky and about waves in general is that I can send a vibration from one side to the other, but each part of the slinky, it only moves a short distance. It either moves forwards, backwards, or up and down, but in either case it doesn't go all the way from here to here. And that's the thing about waves, they transfer energy, the motion carries on through the slinky, but they don't transfer matter. No part of this slinky ever goes from one end to the other, unless of course I let go.